and we're going to talk about static methods. Now, to kick off our discussion, I'm going to create a new project from a template, the command line app template, and we're going to call this static methods example. Now, static methods are methods which are tied to the class definition rather than object instances. And what could be the use of such methods? We're going to take an example here where we are going to construct a very simple calculator. So we're going to create a new class and we're going to call it calculator. Now, our class calculator doesn't do a whole lot. The class will have a no-arg constructor, which is going to do nothing. Now, arguably, these are actually created by default and we don't have to explicitly specify it here, but for the sake of the completeness in this example, I'm going to keep it here. Inside of our calculator, we have the ability to do only one thing, and that one thing is that we are able to add two numbers together. Now, consider first a case where we don't have static methods. The way that we would implement this is by typing in public and say that it's integers that we are adding together, so the result of course will be an integer. I'm going to write public int and then give the method a meaningful name. And we said that it was two numbers, so we are going to call it int a and int b in the parameter list. Now, of course, this is very oversimplified, and we could imagine that our an actual calculator would have more advanced operations than this. But for now, let's just consider this very simple example. So, of course, in order to calculate the sum of the two numbers, we are going to add them together, and we're going to return this result. So I've written that in a shorthand form here. I could, of course, created an integer up here that we could call result, and then just written a plus b. And then instead down here I could have written return result, but we'll stick to the shorthand version for now, since hopefully this makes just as much sense as the other example did. Alright, so given that we are in an object-oriented language, what we need to do in order to use this is we need to create a calculator object. So let's first create some variables that we want to work with in terms of numbers. Num1, and we could call that 5. And then we could add another integer here, num2, and assign it a value of 10. Now, in order to use my calculator, what I would do is I would create a calculator object like this, and then I would write c.add in order to call the add method in the object that c is pointing at with the two numbers that I would like added. And just to get something written to the screen, we could write system out println, and then the result returned by the add method here. So of course what we would expect is a program that outputs 15. So let's try and run it and see what happens. 15 is the output of this program. Now, this seems a bit counterintuitive in a few ways. So for one, it seems a bit hard that we need to create a new calculator object because the calculator object doesn't have a state. The constructor doesn't do anything apparently useful for us at least, and we need to do all of that work and run the calculator just to call this very simple method down here. Is there something that we could have done instead? Well, there is. Instead, we could have made this a static method. So let's call this public static int add instead. Now, this doesn't change a whole lot over here. And we will also see that over here the code is still functioning, and indeed I would be able to run the program with no issue and we would get the same output. But now that I've created a static method, the method lies at class level instead of at object level. This means that I could use the class to refer to the method, and it also means that I won't assume that there is an object instance when working with the method. So static methods can be called directly on the class, and static methods don't require you to instantiate an object of that type. So instead we could just write here 5 to 10, and then of course we could create an output again, system out println, like so. And hopefully what we will see here is that functionally nothing changed in our program. You see, it still makes an output of 15, so functionally nothing has changed so far. Of course, there's a few limitations to this approach. One limitation is that over here, this method cannot use the value of any non-static attributes. So if I had another method, say that we had a method called public static int, what could we call this? Multiply with factor. And this one just takes a single number as an argument. And what it does is that up here we might have a public int factor, and we could give it, of course, a value down here in the constructor, but for now I'm just going to give it a value up here of 5. And down here then, what we would and down here what we could have hoped that we were able to do is we could hope that we were able to say that the value a that we got in here, we would like to multiply with the factor up here. However, this will give us an error. The reason for this is that this one up here is not a static attribute. And seeing as it is not a static attribute, this value ties to an object. This means that in order to access this one up here, we need to be in a non-static context, or it means that we would need to do something which is a bit convoluted, like for instance down here, write calculator c equals ni calculator, and then access it through an object, like so. But this becomes a bit convoluted. Now, if we want to keep this a static method, the intuitive approach to this, of course, would be that instead of declaring this as an instance variable, as an object level attribute, what we could do is we could declare it static, which would solve this problem down here. Of course, here we need to remember that there are some special things about static attributes that we've been covering in the other screencast regarding static attributes. So hopefully this shows you how you could create sort of a utility class that doesn't have any state, that we don't need to instantiate, and where we can use the static methods on a class level.